Okay, this one, we did a survey on commercial stone fruit cold rooms. We measured the relative humidity and temperatures to ascertain possible impact on moisture management. And that we did. So obviously, once again, shrivel is a concern, and we need to challenge, to manage it properly. There's still obviously a pressure on the reduction of plastic and to make it more recyclable. An important aspect is to reduce moisture loss and shrivel in stone fruit is by reducing the vapor pressure deficit by increasing the relative humidity in cold rooms. So the study was to conduct a survey to establish a range of RA levels in stone fruit cold rooms used for pre-packed bins holding accumulation and forced air cooling fruit prior to export, and to ascertain the type of RA systems employed and the type of monitoring. 23 cold rooms in 3 main stone fruit production areas were identified. Loggers were used to monitor temperature and the relative humidity. We also put out questionnaires and asked questions on site on systems used, the function of the rooms, if they use it for just pre-packed bins, for forced air cooling, because some pack houses still use cold rooms for forced air cooling, some's got dedicated rooms, forced air cooling tunnels, and if the relative humidity was monitored and how. The evaluation of performance was according to a scale of above 90% relative humidity is good, between 80 and 90 is medium, and below 80% is poor. So this is results from a pre-pack bin cold storage room that was done in the Sears area. And you can see in that the top one, you can see that the average air temperature was at 2.2 degrees Celsius with a relative humidity of 88.6%. If you look at the bottom graph, you can see that was better air management of 0.5 degrees Celsius and a slightly higher relative humidity of 89.6%. I just made a table to include the dedicated forced air cooling tunnels that they use at some pack houses, and you can see that, and that was typical runs. Obviously, that cold rooms are not, that forced air cooling tunnels are not running the entire time. So I identified areas where they were running and to see what the average RH and temperatures were in the period that they ran, and you can clearly see that some of them were running at very low relative humidities. The P stands for poor, and they were at 76, 72, and 79% relative humidity, and that's not good at all. There were some others that were very good, that ran at 90, 93 and 94% RH, and that's the ideal. That's what you want. And then all the other ones were in the medium range, between 80 and 90. That's not good enough. So it's only those 3 of all of them that was actually good relative humidity levels for forced air cooling. If we look at accumulation rooms, this was 2 rooms done in the Paarl area. You can clearly see that this one was, the top left one was running at 0.4 with 87% relative humidity, and the bottom one was at 0 degrees Celsius and at 89.8. It was much better than the previous ones that we saw. So overall, the pre-packed bin cold rooms exhibited RH results on the higher side of the medium performance range set out in the work plan, with 5 rooms that were between the 85 and 90% relative humidity, 1 room that was in the high 80s, low 90s, and one room in the poor to low medium range at 82%. Data from that forced air cooling done on that dedicated forced air cooling tunnel showed 3 runs done, like I said, in the poor range, 3 in the good, and 17 were in the medium range between that 80 and 90%. The 2 rooms used for forced air cooling had only a medium reading of between 85 and 84%, and some were in the poor range at below 80. And if you do forced air cooling in that low relative humidity, there will be definitely more moisture loss and shrivel that will develop. In the accumulation rooms, 5 of the 11 rooms exhibited relative humidity levels in the high to medium to good range. That was above the 85%, while the rest were below the 85% in the low, medium to poor range. None of the cold rooms that I visited monitored the relative humidity levels or temperature, but only at the readings of the return air as per cooling unit and set point. So they don't have any additional monitoring of temperature or relative humidity. In previous research, it was recommended to aim for a relative humidity of 95% to limit moisture loss from stone fruit and subsequent shrivel, with none of the commercial cold rooms in that year reaching anywhere close to that 85%. So that is one of the issues why we can have possible high levels of shrivel. I also, in one of my next talks, we also looked at the effect of prolonged forced air cooling on shrivel, and you can clearly see that's why it's important to have your relative humidity at a high level in basically all your cold rooms after you've packed your fruit. Thank you very much.